Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this is a portion of distributed forces. So still on locating centroids of volumes, areas, arcs or lines, and the corresponding derivation of formulas or volumes, as well as for the locations of the centroids or center of gravity, which is very important in the succeeding topic on uh, beams subjected to loadings, line loads, concentrated loads, or surface loads. Level 66, an opening is formed in the thin cylindrical shell. Determine the x, the y, and the z coordinates of the mass center of the homogeneous body. So we have here a cylindrical shell and we have here an opening, which is a surface of the portion of the cylindrical shell. So for the cylindrical shell itself, the centroid is here. So barred x is negative L over 2 for the whole shell. Cylindrical shell, barred y is 0 and g barred is 0. For this part, we have to analyze it. Uh, the plane of this arc is also parallel to the YZ plane as shown. So this is the plane, then we draw from the center to this end of this arc, and this angle is 45 degrees, which is this. So half of 45 degrees is 22.5 degrees. So that's the centroid of this imaginary arc, and this arc is to be moved along the x-axis to form this surface of the arc or the shell. So that's the location of the centroid, 22.5 degrees. This is also 22.5 degrees from the center to the centroid of this arc. It is r sine 22.5 degrees over 22.5 degrees converted to radians. So we multiply further by pi over 180. So that's r sine 22.5 degrees over 22.5 degrees times pi over 180. So that's it. For the surface area, 1, it is circumference times length. So circumference is 2 pi r. The length of this path is 2 pi r. Then times length in that direction, L. So 2 pi r L. So it's like if you cut this shell and flatten it out, it looks like a rectangle with the length 2 pi r and in that direction L, so 2 pi r L. Same is true with this. So this is the length and this is supposedly the width or height of the rectangle, which is curved, and it is radius times central angle in radians, then times length in that direction, which is 3/8 of L, and it is treated negative because it is an opening. So surface area 2 is negative r times pi over 4, radius times central angle 45 degrees or pi over 4 times length in that direction, so 3L over 8. So the surface area is r times pi over 4, the length of this curve, times that dimension, 3L over 4, 3L over 8. So that's the surface area, negative 3 pi RL over 32 for this opening. Therefore, the net surface area is 2 pi RL minus negative 3 pi minus 3 pi RL over 32. So it is 61 pi RL over 32. Applying Varignon's theorem, but remember x sub C1 of the cylinder it's here, negative L over 2, and x sub C2 is here along this path. So the distance is negative L over 8. then half of 3L over 8. So negative L over 8 minus 1 half of 3L over 8. So the centroid is here, and the distance from the YZ plane to that centroid is this. So negative 5 over 16L. By Varignon's theorem, 61 pi RL over 32 times x sub g equals 2 pi RL times negative L over 2 minus 3 pi RL over 32 times negative 5 over 16L. Cancel pi RL, simplify, solve for xg. X sub g is equal to negative 497 over 976 L, and that is approximately negative 0.5092 L. Then for y, so y sub c1 is 0 for this part. It lies on the centroid by symmetry, while y sub c2, for this case, it's here. This is the y-axis, so it is in this direction, so negative. So this distance, which is this, times cosine of 22.5. So if the centroid is here, this is the distance. So it is negative r sine 22.5 over 22.5 degrees times pi over 18 from here, center to that centroid. Then the horizontal projection is multiplied further by cosine 22.5 degrees, and it is negative. So y sub c2 is negative r sine 22.5 degrees over 22.5 degrees times pi over 180 times cosine of 22.5 degrees. In decimal, y sub c2 is negative 0.900316 r. By Varignon's theorem, 61 pi RL over 32 YG equals 2 pi RL times 0 minus 3 pi RL over 32 times negative 0.9000316 R. So cancel pi RL again, then solve for YG. YG is positive because this is positive. So YG is positive, it's somewhere there, 0.04428 of R. Then G sub C1 is also 0, while G sub C2 is above the y-axis, so it's positive G. It is R sine 22.5 degrees over 22.5 degrees times pi over 180, that distance, and this distance multiplied further by sine of 22.5. So G sub C1 is 0, G sub C2 is positive R sine 22.5 degrees over 22.5 times pi over 180 times sine of 22.5 degrees. And in decimal, it is equal to 0.372923 R. By Varignon's theorem, 65 pi RL over 32 times G sub Z sub G equals 2 pi RL times 0 minus 3 pi RL over 32 times 0.372923 R. So it's negative, solving for G sub G, Z sub G. It is equal to negative 0.01834 of R. Level 67, determine the Z coordinate of the mass center of the homogeneous quarter spiral shell, which has a radius of R. So let's reveal this part, quarter arc here, and have it revolve 180 degrees. So we have to show this surface, and the height is y. So for the solution, so this is this part here, this part, and have a vertical strip, which is that the height is z. So we are on the x-axis, and this is dx, this is ds. This ds is to be revolved through 180 degrees, and the end view, if you are in the y-axis, so this would be the shape on the y-axis. So this is the surface area, which appears to be an arc if you are on the y-axis. So this is what we see. Then the height is still z, or the radius is z. So therefore, that's the location of the centroid, and this is treated as an arc. Therefore, the location of the centroid, g sub c, is 2r over pi, or the radius is z, so 2z over pi. So that's 2z over pi. So that's ds, and the surface area is ds, integral of ds times the length of this arc, which is this, the length of this path when revolved about the y-axis is, when revolved about the y-axis, this is the generated arc. So the length of the arc is ds times the length of the strip or differential element is ds, and the length of the arc or distance traveled by the centroid is this circumference here, which is pi times radius, pi times z. So differential surface area is ds times pi times z, or z times pi, which is the length of that path, which is this. So surface area, therefore, is pi integral of z ds, where ds is square root of 1 plus dz dy quantity squared times dy, because this is the z-axis, this is the y-axis, so we use ds square root of 1 plus dz dy quantity square dy. So it's like if we imagine this is x, dy y is x, it's like 1 plus, and z is y, so 1 plus dy dx quantity square dx. So it's like that. Then times z, this is this. So what is z? So since this is y, that's z, and this is r, so z is square root of r square minus y square. So that's the radius, this is y, that's radius r, so z is square root of small r square minus y square. Then the derivative of z with respect to y is negative 2y over 2 square root of r square minus y square from calculus. So cancel out 2, and if we square dz dy quantity square, so it is y square over r square minus y square. So substitute here. Surface area is pi integral from 0 to r of square root of 1 plus y square over r square minus y square. Then z, which is r square, square root of r square minus y square dy. If we simplify the value of the radical here, it is r square minus y square plus y square. So the numerator will be r square, and the denominator will be r square minus y square. So square root of r square is r. Then we have square root of r square minus y square in the denominator. So surface area is pi integral from 0 to r of r over square root of r square minus y square times square root of r square minus y square dy. So we can cancel this, and what remains is pi r, which is constant. Integral of dy is y from 0 to r. So surface area is pi r times y from 0 to r. So r minus 0 is r, so pi r times r, surface area is pi r square. Then by Varignon's theorem, we only need z coordinate of the mass center. So surface area times g sub g is equal to integral of g sub c, differential surface area. So the differential surface area from here is, this is not yet integrated, so the simplified form of differential surface area is pi r dy from here. and g sub z is 2z over pi. So pi r square g sub z equals integral of 2z over pi times pi r dy, which is that cancel out pi. So we have pi r square g sub z equals 2r integral of g dy, where z is square root of r square minus y square from here. So from calculus, when the integrand involves constant square minus y square, we put the variable equal to r sine of theta. So that means dy is r cosine theta d theta. So let's define this in a right triangle. Sine theta, so if this is theta, sine theta is opposite to y over hypotenuse r. And you also experience, so therefore this adjacent side is square root of r square minus y square, which is in terms of r and theta, r cosine theta. So square root of r square minus y square is r cosine theta. Substitute and take note that when we substitute the lower limit, 0 equals r sine theta is 0 over r, so sine theta is 0, arc sine of 0 is still 0. But when y is r upper limit, r over r is 1, arc sine of 1 is pi over 2. So we change the limits to 0 to pi over 2. So pi r squared g sub z equals 2, cancel r, so pi r g sub z, 2 integral from 0 to pi over 2. This is r cosine theta, and dy is r cosine theta d theta. So g sub z therefore is 2r over pi, because we also cancel 1r, integral from 0 to pi over 2 cosine square theta d theta. We can evaluate this by Wallay formula. N minus 1, so 1, stop. Then in the denominator, sum of exponents, so 2, stop also. So 1 over 2. Then because this is even, times pi over 2. So this integral by Wallay formula is pi over 4, 1/2 of pi over 2. So g sub z is 2r over pi times quantity 1 over 2 times pi over 2. Again, the 1 here is 2 minus 1. Then remember, we have to stop. Then the 2 here is the sum of exponents of cosine and sine, but sine is 0, so there's no sine function, so it's 2. Stop also. Then there is alpha. Alpha is pi over 2 when both m and n is even, so 2 is even. Sine raised to 0. 0 is treated even, so that's why we have pi over 2. So it's pi over 4. Cancel out pi, so we have r over 2 for g sub z. So that's it for this problem. Level 68. Determine the volume and the y-coordinate of the center of mass of the homogeneous solid truncated right circular cylinder shown. So here is the given figure, and we should consider a slab, rectangular slab. The variable here is x, so the thickness is dx. This height is y, and this is z, parallel to z. That's y. So if the distance from the centroid of the slab from the yz plane is x, so this is r minus x. So this is x distance. So it will be clear on this figure here. So this is z from the y-axis. Imagine we are on the y-axis, positive y-axis z. This is x, so this is r minus x, which is this. And from the figure, z is square root of r square minus x square. So volume is times 2 of integral of the volume of this differential element, which is a rectangular slab yz dx, times 2 because we also have a slab on the other edge there, parallel to the yz xy plane there. So times 2, this is the other slab here. So from the figure, z is square root of r square minus x square, and by similar triangles, y as to r minus x equals h as to 2r. Y as to r minus x equals h as to 2r. So y is h over 2r, quantity r minus x. So substitute here, volume is 2 times integral from negative r to r for x negative r to r of y h over 2r r minus x, then z square root of r minus x squared dx. Cancel 2, so volume is h over r, integral from negative r to r, expand, so r square root of r squared minus x squared dx, then plus h over 2r, this one, supposedly h over r, but I'll just make it h over 2r because I multiply this by 2, and supposedly minus, but I just make it plus because the minus sign is here, and it's the same as if we cancel 2 and expand, second term is h negative h over r, negative h over r because we cancel 2, then x, which is this, square root of r squared minus x squared. So I intentionally do this because in preparation to the integral of this expression, which is if we put u be r squared minus x squared, the differential is negative 2x dx. So this is in the form integral of u to the 1/2 du. The integral of u to the 1/2 du is u to the 3 halves over 3 halves, which we will see here. So this is cancel r, so volume equals h integral from negative r to r of square root of r squared minus x squared dx. Then for this part, this is h over 2r, then 2/3 reciprocal of 3 halves, u r squared minus x squared to the 3 halves from negative r to r. So if we substitute the lower and upper limits here, r squared minus upper limit r squared, it is 0. Lower limit r squared minus negative r squared, it is also 0. So the whole of this is 0. So let's focus on this. In this integral, when the integrand involves constant square minus variable square, we put the variable with our experience with integral calculus as r sine theta. So x is r sine theta, differential of x is r cosine theta d theta. And we define this in a right triangle. This is theta. Sine theta is opposite x over hypotenuse r. So therefore, by Pythagoras theorem, this is square root of r squared minus x squared, which is in terms of r and theta, r cosine theta. So square root of r squared minus x squared is r cosine theta. And when x is lower limit negative r divided by r, so negative 1, arc sine of negative 1 is negative pi over 2. When x is upper limit r, r over r is 1, arc sine of 1 is pi over 2. So volume is h from the integral from negative pi over 2 to pi over 2 of square root of r squared minus x squared, which is r cosine theta. Differential x is r cosine theta d theta. So volume equals hr squared, then integral of cosine squared theta d theta, and cosine squared theta, its identity is 1 plus cosine 2 theta over 2. So the integral is, so volume is hr squared over 2. Integral of d theta is theta. Integral of cosine is sine 2 theta over 2 from negative pi over 2 to pi over 2. Take note that sine of 2 times pi over 2 is sine of pi 0. And lower limit sine of negative pi is also 0. So the whole of this is 0. Then we have theta, pi over 2 minus negative pi over 2 is pi. So this is just pi. The volume therefore is pi r squared h over 2. Then by Varignon's theorem, volume times yg equals integral of y sub c dv, where y sub c is, because this is the centroid, this is rectangular slab, y sub c is there at the center. So in terms of y sub c is just y over 2. So volume yg equals integral of y over 2 dv. dv is 2yz dx. Cancel 2. So volume equals pi r squared h over 2 yg integral of y square from negative r to r. Y square is h over 2r, r minus x, quantity square, then z square root of r square minus x square dx rather. So expand pi r square h over 2 equals yg equals h square over 4r square, then integral negative r to r of r square minus 2rx plus x square, then square root of r square minus x square dx. So if we expand, cancel r square, so we have h square over 4 integral of on the right side. So let's just copy the left side. So we have h square over 4, cancel r square, integral of r square x square dx. Then the middle term is similar to this. So that's why I ignored the middle term, because it will give us 0 value. Then the last term, h square over 4r square, which is this, then integral of x square, square root of r square minus x square dx. So again, the middle term is ignored because it will just give us 0 value with our experience here. So let's focus first on the first term. Originally, the first term is h square over 4, because we cancel r square, then integral of r square minus x square. Without experience with integral of r square minus x square, the result was this, right? And h is constant. So if we compare, that means the result of integral of r square, square root of r square minus x square dx would be pi r square over 2, which is this, pi r square over 2. And h square over 4, because we cancel r square, is this. And the result is pi r square over 2. We just ignore h because it is constant from here. So I apply experience here from this integration of the first term. So I hope it is no longer an issue. So h square over 4, because we cancel r square. And remember, the integral of square root of r square minus x square from negative r to r is pi over 2 r square from here. We just ignored h because that is the constant here. So I hope you follow the explanation, or else the solution would be long and it will give us the same results. So let's focus on this integral, and we will call that I2. So I2 is h square over 4r square, integral from negative r to r of x square, square root of r square minus x square. And with our experience, we set x equals r sine theta again. So that's why we have here r sine theta square, which is x square. This is r cosine theta, and dx is r cosine theta d theta with our experience. So we have r to the 4th divided by r square. So this is r square h square over 4. Then integral of sine theta square cosine square theta, or sine theta cosine theta quantity square d theta. The identity of this is sine 2 theta over 2. So I2 is r square h square over 4, integral from negative pi over 2 to pi over 2 of sine 2 theta over 2 quantity square d theta. So that would be r square I2, r square h square over 16. Then sine square 2 theta is quantity 1 minus cosine. So sine squared 2 theta, the identity is 1 minus cosine 4 theta over 2. So I2 is r square h square over 16, integral from negative pi over 2 to pi over 2 of quantity 1 minus cosine 4 theta over 2. So we double this, d theta. So I2 is r square h square over 32, integral of d theta is theta. The integral of cosine 4 theta is sine 4 theta over 4 from negative pi over 2 to pi over 2. So let's focus first on sine 4 theta over 2. Sine of 4 times pi over 2 is sine 2 pi. Sine 2 pi is 0. Then if you substitute the lower limit, that becomes sine of negative 2 pi. Sine of negative 2 pi is also 0. So it's useless to divide it by 0 because 0 over 4 is still 0. So the whole of this is 0. And with our experience, theta, pi over 2 minus negative pi over 2, this is just pi. Therefore, I2 is pi r square h square over 32. Then substitute uh, here, and this is I2. So pi r square h over 2 yg equals pi r square h square over 8. Then plus I2, which is pi r square h square over 32. So we can cancel pi r square. So the answer is in terms of h. So finally, yg can now be found 1/8 of h plus 1 over 32 of h times 2 over times 2. So it is 5 over 16 of h. So remember that for this truncated solid cylinder, the location of the centroid parallel to h from the base, circular base, is 5 over 16h. Level 69, determine the x-coordinate of the mass center of the solid homogeneous body shown. So we now apply the results, the y-coordinate of the centroid of the result in problem 68 here, because this is a solid. It consists of solid right circular cylinder and a truncated solid right cylinder. So for the solution, the centroid of this right circular cylinder, if the length or height is 2r, is r over 2 from the base. So call that volume 1, and this is r. So 2r over 2, or r. Then remember that for this part, the location of centroid from the circular base along the height here is 4r minus 2r. So 2r is 5 over 16. Remember from the result in problem 68, level 68, 5 over 16 of h, and h is 2r. So I'll just call that V2. Then the volume is, remember, pi r square h over 2. And this distance is 5 over 16 of h, where h is the height of the truncated prism, which is 2r, 4r minus 2r. So it was y, but here it's barred x, it's the same. You just imagine that this is the y direction also. So volume 1 is area of the base times height, which is pi r square times 2r. So it is 2 pi r cubed. Volume 2 is pi r square h over 2, where h is 2r. So pi r square h over 2, where h is 2r. So pi r square over 2 times 2r is pi r cubed. So the total volume, therefore, is volume 1 plus volume 2, 3 pi r cubed. Then we apply Varignon's theorem in locating xg. So volume xg equals volume 1 xc1 plus volume 2 xc2, where xc1 and xc2 are already shown here. So xc1 is r, xc2 is not 5 over 16h, its distance is from here. So its xc2 really is 2r, this is already 2r, plus 5 over 16 of h, where h is 2r. So 3 pi r cubed xg equals 2 pi r cubed times r plus pi r cubed times 2r plus 5 over 16 of h. 5 over 16 of h. Then we have 2r here, because we reckon this, we refer this centroid from the x-axis from this end. So 2r plus 5 over 16 of h. So 2r plus 5 over 16 of h, where h is 2r. So from there, we can solve for xg. So 3 pi r cubed equals 2 pi r to the fourth plus 21 over 8 pi r to the fourth. So cancel pi r cubed and solve for xg in terms of r. So xg is equal to 37 over 24 of r. So that's it for this level 69 problem. Level 70 problem. The three legs of a small glass top table are equally spaced and are made of steel tubing that has an outside diameter of 24 mm and a cross-sectional area of 150 millimeters square. The diameter and the thickness of the table are 600 mm and 10 mm respectively. Knowing that the density of steel is 7,860 kg per cubic meter and of glass is 290 kg per cubic meter, locate the center of gravity of the table. So this is the assembly. We have identical three legs and composite legs also per part, and we have a plastic circular table on top, circular plate on top. So let's draw the table and one side of the leg. And take note that here it is clearly denoted that R is from the center to the inner arc, not the uh, mean radius. So we have to add the radius of this tubing, which is 12 half of 24. So to see that, let's call that's the center of gravity of the entire assembly, and we'll call that HG. So this is the view. This is the circular table, front view for example. 10 mm thick, radius is 300 mm as stated here. 600 mm diameter, so 300 mm radius. The thickness is 10, and that is made of plastic. I'll call that MP. That's the centroid. This is M of tubing 1. This is the centroid of the entire assembly. Remember, there are three tubings here. And this is HG. And this is the center of this lower tubing. The original distance from here up to the inner arc is 180. And this is 280 also to the inner arc. Therefore, we add 12 half of 24. So this is now 180 plus 12, so that it will be from the center to the median arc here. So that would be the radius center of the cross section. So 192, 280, so it is clear here, inner. 280 plus 12 is 292. And the radius of the tubing is 12. That this is also 12. So that mass of plate is plastic to 190 density times volume, pi times 0.3 square times 0.01 the thickness. So M of plate is M of table plastic is 6.1921 kilograms. For MT1, it is area times length of path pi r over 2, pi times 0.292 over 2. The area is 150 mm square divided by 1000 square to convert it to meter square. Then the length of the path is pi r over 2, pi times 0.292 meter over 2. Remember, 292 is 280 plus 12, so that it would be from the center really. Then times 3 because there are three identical legs. So MT1 is 7860 times 150 over 1000 square in meter square cross-sectional area times length of path pi times 0.292 over 2, then times 3. Pi r over 2 times 3. So it is 1.6223 kilograms. Then for MT2, it is 7860 times quantity 150 over 1000 square pi times 0.192 over 2, then times 3. So it is 1.066 kilogram. So the distance from here to here, bottom surface of the circular table, is 12 plus 192 plus 292 plus 12, and that is 508. So the total mass therefore is 6.1921 plus 1.6223 plus 1.0667. So it is 8.8811 kilograms. So this distance, as I said, is 12 plus 192 plus 292 plus 12. So MHG equals MPHCP plus MT1 HCT1 plus MT2 HC2. That's by Varigdon's theorem. So this is 508 mm, 12 plus 192 plus 292 plus 12. Then the value of HCP is 508 plus half of 10, 5. So 513 mm. So that's 513 mm HCP. Then this this distance is 12 plus 192 plus 2r over pi. So 2 times 292 over pi. So 12 plus 192 plus 2 times 292 over pi, that's 389.89 mm. Then this distance is 12 plus 192. This distance is 2r over pi, so minus 2 times 192 over pi. The radius is 192. So that would be 12 plus 192, 204, minus 2 times 192 over pi, and that is HCT to 81.77 mm. Substitute here, 8.8811 equals 6.1921 times 513 plus 1.6223 times 89.89 plus 1.0667 times 81.77. So Hg therefore is equal to 48.7 mm above the floor. So that's it for this series of problems.